Hello calculus students, welcome to the lesson on the limit comparison test. And before we get to what this actually says, let's look at a motivating example as to why this test is useful. So if you recall from the last video or maybe a couple videos ago, we have this example here and we try to use the direct comparison test to this, and we said that this series is very similar to the p-series with n equal to 1/2. However, the p-series is greater than this one and the p-series diverges, so there's nothing that we can really say. There's nothing that's very useful in making this direct comparison. Okay? But maybe your intuition can lead you a little bit further here, and if you look at this series, you can say, well, I know it's not exactly like this one, but it's very close. In the long run, the square root of n is what's going to dominate everything. So if you just go with that, logically it seems that this series should also diverge, because these two series, they're not the exact same thing. One of them is bigger than the other, but in the long run, they're going to behave the same way, because you just have square root of n here and a constant. And in the long run, the square root of n is going to dominate everything. And your intuition, if you thought that, would be totally correct, okay? Because this is what's called a limit comparison test. And it says, let's say you have two positive infinite series. In general, in these lessons, we're talking about infinite series, a sub n, b sub n. If the limit of the ratio of the two of them is finite and positive, okay, so can't be 0. If the limit is either infinity or 0, then this test does not work, so it must be finite and positive. Then either both of the series will converge or they both diverge. So this is just a way of saying that these series that are very similar to each other will behave basically the same way. And so let's put that to work in our previous example. So if you look at our first series, which is n equals 1 to infinity, I had 1 over the square root of n plus 5, and then the second series that I had was n from 1 to infinity, 1 over the square root of n. So if we apply the limit comparison test, if we just take each of these terms, okay, and let's take the limit as, let's put this term over this one. It actually doesn't matter because the result has to be finite, and if the result happens to be finite, then it doesn't matter which one you put over the other, and positive. Okay, so let's take the first one, 1 over root n plus 5, and divide it by this one. In other words, just multiply that by the reciprocal. Okay. And take the limit here as n approaches infinity of that whole statement. And then we can do some simplification. This is the limit as n approaches infinity of n to the 1/2 divided by n to the 1/2 plus 5. Okay. So if you look at here, you can see that by using leading terms, n to the 1/2 and n to the 1/2, in the long run, this is going to behave like n over n to the 1/2 over n to the 1/2, which is equal to 1. So the limit comparison test applies since this limit is finite and positive. So that means that either both of these will converge or both of them will diverge. And since we know that the second series, 1 over, this is really n to the 1/2, right? The square root of n and n to the 1/2 is the same thing, diverges by the p-series test. Then the other series must also diverge. So this is a good example of the limit comparison test. So